Hi! In this video, we'll go step by step through setting up distributed tracing in microservice architecture using Spring Boot 3, OpenTelemetry and Jaeger. I'll also show you what not to do. It will save you time, keep you from getting lost in dependencies or stuck experimenting for hours. And finally, the most exciting part. To make debugging way more effective, I'll show you how to add logs directly into your traces. It's a powerful but rarely mentioned technique that most people don't even know about. But for now, let's get started. First, let me briefly recall what distributed tracing is and how it can help us. Distributed tracing helps us to track requests as they travel through microservices and providing visibility into entire flow of data across services. This is especially useful when we need to identify bottlenecks or slow requests. Without tracing, figuring out where delays happens in the microservice system can be a real challenge. To make it possible, we mark every external API request with a common trace ID, and each internal call between microservices gets its own span ID. This allows us to tie together different parts of the system and see the complete picture of how data flows through the services. In the previous video, we set up distributed tracing using Micrometer and Zipkin. However, based on my experience, Zipkin isn't always the most optimal tool for all situations. In this video, I want to explore an alternative stack based on Jaeger. Jaeger allows us to process data flows better than Zipkin. It also has better community support, integrates with OpenTelemetry, and supports many backends like Elasticsearch, Cassandra, and other data storages. In general, the amount of materials in the network about configuring interaction between the Spring Boot application and Jaeger is very large, but many of them are either incomplete or lead down to wrong path or are no longer supported. For example, as one of the methods I wanted to consider, using the OpenTracing library, which was very popular in the Spring Boot stack before. But after spending some time trying to run it, I found that with the release of Spring Boot 3, OpenTracing is no longer supported. First, I saw a mention of it on the Stack Overflow. That comment points on issue in the OpenTracing GitHub repository. As you may see, it even includes a suggested workaround, but in the long term, the better approach is to migrate to OpenTelemetry, because more than a year has passed since the issue was opened and nothing has changed since then. So since OpenTracing has reached its end of life, and for now the recommended way to connect Jaeger is using OpenTelemetry. But here we also have a choice, using Jaeger directly or connecting it via OpenTelemetry Collector. The first way is more straightforward and simple, but using the collector approach is more powerful, flexible, and preferable for bigger projects. In this video we'll start from the base using the first approach, but if you're aiming for a full observability setup with the collector logs, Grafana, and Loki, that's coming in the next video. Now let's continue and take a look at the project that I will use to show how to set up distributed tracing. Here we have two microservices, ping and pong, each in a separate Gradle module. The build Gradle file is empty. The other one is empty too. And all common dependencies are moved to a root build Gradle file. For now we need only Spring Web and Lombok, so I've commented the other dependencies. Now let's take a look at the controllers. Both microservices are exactly the same and have a single endpoint which processes GET requests with a single parameter, threshold. The whole request handled right aside the controller method, so let's see how it works. First we generate a random value between 0 and 1, and if this value is less than threshold, then we continue and send the next request to the other microservice. Then we return a result, which is a combination of the service name and the result from the next call. Otherwise, we just return a game over string. Now let me show you how it works. I'll send a request to one of the services, ping in my case, and we get the full call chain as a result. Let's try again. As you can see, the number of iterations is really random, and we can control it by changing the threshold. Now let's move further and see how to connect our application to Jaeger. To do that, first I'll uncomment these three dependencies. Spring Boot Starter Actuator, we need to configure tracing parameters. Micrometer tracing bridge, as you may guess, is the bridge between Micrometer and OpenTelemetry. And OpenTelemetry exporter. It sent request to the OpenTelemetry collector inside Jaeger. Next, we need to configure OTLP span exporter. I'll make a new configuration for it. Then create a single bin, public OTLP span exporter. Here we need one argument, the tracing URL. I will define it in application YAML later. Now I return OTEL PHTP span exporter, builder, set endpoint, URL, build. Then I'll copy it to the second microservice as is. And define a tracing exporter properties. Set the probability to 1 because I want all traces to go to Jaeger, and enable true. Then define a tracing URL. This is HTTP API URL because I've initialized HTTP exporter. And the last one, we need to start Jaeger. I have already prepared the Docker Compose file. This is HTTP collector port, and this is gRPC port. This one is UHTTP port, and this environment variables activates built-in OTEL collector. Now start Docker Compose and restart both microservices. Then send a few requests. In the logs we can now see trace and span IDs in each row. Now let's check how it looks in Jaeger. I've already opened it. Jaeger is available on port 16686. Here we have services. I'll choose ping, operations, and also time and tax filters. Let's choose last 5 minutes interval, find. Here are last 2 requests. Inside of it we can see all internal calls. Let's open the first one as an example. Here are tags with common parameters. This information is available for each request. We can also check how long each call takes. Now let me show you how to use gRPC protocol. I'll comment out the HTTP exporter and register a new one. Bin OTP gRPC span exporter. The arguments is the same. Return OTP gRPC span exporter builder. Set endpoint. Build. Don't forget to copy this bin to the Pong service. And we also need to update the tracing URL port 4317. Now let's restart the microservices. Go to Postman and send a few more requests. Let's check the result. As you can see, everything works fine. Okay, now we're done with the basic setup, but at the beginning of the video I promised to show you something interesting. And what I mean was logs right inside the traces. Unfortunately, very few developers knows about this feature. And I think you'll hardly find any mention of it online, but it's super useful and it helps you to debug your application much more efficiently. First of all, we need to create our custom logs appender. Let's name it span logs appender and extend it from the appender base. Here we need to rewrite the append method. We will take a current span. Then create an attributes builder. And if the current span is not null, we will put the logger name, log level, and message. Next, we add our custom event to the current span. If the level is error, we'll also set the span status to error. And if the event contains an exception, we'll attach it to the span too. Then we need to attach our span appender to the logger. Let's create a logger configuration for it. First we get a root logger. Get the logger context. From logger factory, get logger factory. And then return context, get logger, logger, root logger name. Now I'll define a post construct method. Create our span logs appender here. Start it and append it to root logger. Finally, copy the new files to the second module. Let's check what we've got. Send new requests and go to Jaeger. Find the traces and see what's inside. It works. Here is our log section. This is our message. Here is a similar one, and we can find it in other traces too. Now let's see how an error message looks. I'll throw it in the Pong controller. Here I throw a new runtime exception with a custom message. Restart services. Send several requests. Update the traces list. Now we can see log records, info log record, error, exception stack trace, and if we go to the Pong service trace, we can find the original exception there. So that's already pretty helpful, but we can make it even more informative. Right now it's not very obvious because we're working with the GET requests and we can already see the path and query variables, but it would be awesome to also see post request payloads, headers and client info. And before we do that, if you find this video helpful or you've learned something new, please give it a like and consider subscribing. It really helps me to keep going and make more content like this. Thanks a lot. So, we want to add the requests login. First, let's create a DTO and move the threshold parameter into it. Add the data annotation, then go to the controller and copy the ping method. Annotate it with the post mapping instead. Remove the threshold path variable and replace the argument with the API request DTO. Replace by the request, get threshold, and here too, replace. I'm not removing the original method because I don't want to change the Pong controller too. It still calls the get method. So I'm leaving the original method as is. The new one is just another entry point for demonstration. Now we need to add a new bin in login configuration. Bin, public, common request login filter. Now I call set include payload true, set include headers true, set include client info true, set include query string true. We could also limit the max payload size. Let's also customize the message prefix. And we definitely want to prevent login credentials. Now return the login filter. Copy the login filter to the second module. Also, this filter needs debug login level to enable it. Now I'll remove the test exception and restart services. Go to Postman. I have already prepared the post request with a single payload parameter. Let's send it and go to Jaeger. Update the traces list. Here are the internal requests. This is the GET request with 2 new log records. And here's the our post request. Let's expand it and see the request info. Post request, user again header, and all the other headers. And here is the second log record with the payload information. Well, that already gives us a pretty solid setup, but we're just scratching the surface. In the next video, we'll take this setup to the next level. I'll show you how to connect Jaeger through the external OTEL Collector, and we will explore a bunch of new things around OpenTelemetry. Don't miss it, and see you soon.